Hi, I'm Scott Jacobson, Director of Product Marketing here at Cadence Design Systems. Today, we're going to talk about an area of automotive electronics and its influence on memory model requirements. This is part two of a series. In the first part of the series, we talked about the market sizing of the automotive electronics market for memories. Today, we're going to talk about the drivers. What are the drivers from this market that are changing the requirements for memory models? One of the first requirements that we're going to talk about here is LiDAR, the growth in LiDAR. So for advanced autonomous driving systems, LiDAR is becoming a requirement. It keeps you from running into things in your environment, recognizes when you have obstacles in front of you. It's based on original basis of the system was a mechanical beam steering. That is transitioning over to flash, and solid state is expected to dominate LiDAR by 2025. So that's a new requirement that's going to introduce more consumption and more requirements on the flash side of automotive electronics than have previously been required. So one of the biggest drivers in the automotive electronics industry affecting memory consumption is autonomous driving, or AD for short. Autonomous driving has levels of complexity. Level 0 is really no automation. Majority of vehicles today are level 0. Level 1 is really ADAS, which is automated driver assist systems. A level 1 autonomous driving solution really has one ADAS system at a time. So one of things like automatic braking, or stability control, cruise control, lane keeping assist, those kinds of things. Level 2 is really another ADAS level with multiple functionalities in tandem. So think of a situation where you've got something in front of you, you have to brake and keep in your lane at the same time. So that's two systems, automatic emergency braking and lane keeping assist, simultaneously being required. Level 3 is the first level of really autonomous driving only under certain conditions. So maybe it's automatic navigation or those kinds of things, but it's only under certain condition. Level 4 is autonomous driving under all conditions, but the human's really a passenger. There's still controls in the car. The human's a passenger, but can take control at any time. Level 5 autonomous driving, which is the Jetson-like future, no human vehicle controls. So level 5 is truly autonomous driving, if there's such a word. Next generation DRAMs required for autonomous driving as kind of a preview of where this is going. For 2018, this looked like GDDR6 to provide a high bandwidth solution for these level 2 and level 3 systems that are coming out. By 2020, LPDDR5 is going to be required with a wider capacity because of the performance requirements for the system throughput. HBM is going to be required for 2020X with a smaller form factor and higher bandwidth. Now, the next driver we're going to talk about is one that I've mentioned already, and that's ADAS, which is automated driver assist systems. Starting at level 2 with ADAS, level 2 is one system at a time. It's perfectly suited for DDR3 and LPDDR3 memory technologies. Level 3, however, where we have two systems at a time, is going to require DDR4 and LPDDR4X and LPDDR5 for those kinds of complexities in two systems at a time. Now, the level 3 ADAS system is predicted to require over a terabyte per second of performance. Level 4 requirements are still kind of TBD. They're a little bit future looking yet. So as far as platform requirements or needs, by 2021, ADAS is going to need greater than 60 gigabytes of storage and greater than 200 gigabytes per second of performance. LPDDR4 is going to be well positioned for ADAS and also for IVI adoption. And that leads us to our fourth driver here for memory models, which is in-vehicle infotainment systems. So this was the original driver for the whole automotive electronics expansion in memories, right? The DRAM requirements for infotainment systems are high bandwidth, quality, robustness, energy efficiency, scalability, early adoption of technology. In 2018, IVI systems are going to be, basically 2 different SoCs per electronic control unit. Those are going to be driving 1 to 2 displays. LP4 will be there in 2018 at 50 gigabytes per second at 8 gigabyte configuration capacity. Storage will be around UFS and eMMC, currently available technologies. But you look 3 years in the future from that, 2021, the IVI concept goes into an integrated cockpit with cluster and infotainment. So a single SoC solution is predicted for that market with a higher performance because it's going to be driving 1 to 4 displays, 85 gigabytes per second performance requirement at 16 gigabyte configuration. It's going to need LPDDR4X and LPDDR5 in order to keep up with that. And the storage is going to be 2x of what UFS is capable of today. And also the hard disk drives are going to transition to solid state drives. And then 3 more years into the future beyond that, then the car really becomes a central computer on wheels. Extended number of displays, you have multiple SoCs internally connected, up to 10 displays, and then it introduces storage class memory requirements, things like GDDR6 and HBM and similar memory technologies, memory class storage and central storage. This is a quick run through of the drivers required, or the drivers and their memory model requirements from the automotive electronics section. This is the end of the second stage of this presentation. Tune in for the third part where we talk about the technology implications of this. Again, I'm Scott Jacobson, Product Marketing Director here at Cadence Design Systems. Please go to www.cadence.com for more information.